Hi everyone, my name is Ling. Thank you for coming to this presentation. I guess I'll go over a quick background. So I come from a Silicon Valley startup, lifestyle. My background in blockchain is Solidity development as well as JavaScript infrastructure development for smart contract enabled dApps, decentralized applications, as you know. Before blockchain, I worked on a variety of projects that, where common things in mind were like, how are we going to build this system out to be usable right away? How are we collecting user data, like say on this mobile app? How are we improving iteratively on the progress of this? And what I want to show you guys is how I want to bring in those elements from, what I've learned before and how I have adapted it to blockchain development. So I guess at a high level, I'll go over what, what's like the base unit of these decentralized applications. This is where you want to focus the UI on, and those are the transactions. A transaction would be either when one party exchanges Ether or tokens to another, or something very specific, a very specific function gets executed on the Ethereum virtual machine. Part two, going over tools that any rational developer would use right away to basically just get his startup, get his application off the ground. And then part three, putting it together, seeing what patterns currently are in play, what has worked for companies that are either in talks of raising very large rounds, people aiming for the moon, so to speak. Okay, and I guess I'll skip through that part. All right, so at the very core, Ethereum is centered around transactions. The individual unit is the account, and then your account represents how you're going, how the money that comes in, that comes out of your dApp is able to either create new value for the user or create a new market that hasn't been available before until the blockchain. So at its very core, these transactions are exactly the thing you want to make sure that the user's experience with is certain or solidified. So I'm going to start with a quick example, right? So a lot of people want to think about transactions in a very technical sense. I'd say, even as an engineer, just think of it from a everyday sense, right? You're at Whole Foods, you're buying some, I don't know, some kale. You insert your credit card into the reader. You look at the cashier blankly for maybe an awkward 20 seconds, and after, that amount of time, the cash register beeps and you're good to go, and the receipt starts printing and you're on your way, right? So this concept has been ingrained in people's minds, since a very young age, since the first time they bought something with a debit card, right? What's interesting about transactions in the Ethereum network is that it actually behaves more or less the same. How does it work? I'm going to just cover it. You sign the transaction object with your private key. It's encoded into binary. You use your Web3 API to send the raw transaction. If you're using MetaMask, it just abstracts away that layer, but deep down, that's still what happens. Once you send it to the network, you get this transaction hash right away. It's 200 milliseconds, the same time as a web request, right? So with that hash, you can go on Etherscan and basically stare at a spinning circle that will eventually tell you the final state of your transaction. And what this means is when you create an application, you want to mimic this process that they're used to onto the app. So let's say that I can give one example. Let's say you're using a payment gateway for the next dApp that makes your storage, your self-storage experience better on the blockchain, or maybe a dApp for health medical records, right? Every time the user sends the transaction, you need to let them know that at each point, right, when it gets broadcasted out to the via Web3, you get the transaction hash, and you let them know that this transaction is currently pending, but up to this point, you did the job right. You've used the application correctly. After that point, you go over, in a technical sense, what you would do is you would create a polling object. This would be like using a desktop JavaScript React application, right? You would create a polling object that constantly takes the transaction hash and looks up, is this done yet? Is this done yet? When at the very moment that it's done, the user should be notified as well. There should just be this notification on the screen or on your mobile app if it's a mobile app, and that tells the user, okay, like not only have I done the primary use case of the app well, but I know that my money is safe. The money I worked hard to like save up and spend is now being put to good value. This covers technically what happens in MetaMask. This is a tool that everyone, like as a developer, should be integrating into their app right away. I'll go over it briefly. What you see on the bottom is in the Chrome browser, you have your JavaScript engine that's compiled with a V8 engine. And then you have the typical window and document object, the DOM. This is Web 1, essentially. With MetaMask, what it does as a Chrome extension is that it injects, it pings off of Infura, which is, just think of Infura as like an AWS for your Gathering parity. But a lot of people use Infura for faster setups as well. It gets the provider and the Web3 object from Infura, and then it overrides the core transaction methods from Web3, like send transaction, invoke contract call. And then every time, what it overrides it with is every time a user does that, it pops open a notification and tells them, okay, you're ready to sign, let's go. I also touched up on one point. On the mobile side, there's a new application called Trust Wallet that you could just think of that as the MetaMask on mobile. I would say from my experience that if you're building any app that deals with money, shopping, or whatever, mobile conversions are 3 to 5 times more higher in ROI. So if your goal is to start creating real income streams, start thinking about mobile development as well. This is a typical pattern for what you might see in a distributed app, decentralized app. What you have in the middle is either your parity, your Geth, or the Infura node. The application, again, can be React on the front end as a desktop application. It could also be React if you're using mobile UI web views. So what happens is that for now, there's no way to escape the fact that you need some sort of local server, right? So this entire transaction lifecycle that I talked about in the previous section is required for the server to babysit, so to speak. If the client ever leaves the application, if the client ever decides to, try to break the app or accidentally breaks it, we want the server to still have that transaction hash to be ready to update any dependent parties on what exactly happened to that transaction. As dApps build, it's not always just one single, like you with your CryptoKitty and there's like a CryptoKitty store, right? There's going to be tens or like 5 to 10 adjacent dApps that will be feeding off data and transactions from your dApp. Just think of how interconnected the web is right now, right? So the final point I want to make is as we figure out that these dApps have a real use case, they are unlocking new markets, we want to implement them with a set of microservices and adapt all the information that we currently have so that the transactions from the server get broadcasted to all the qualified recipients. Thank you.
Where can they find out
So I have, yeah, if you guys want to learn more, I have a YouTube channel. I can post that in, like, I guess, a Telegram. I also have my email listed. I can send that out, or you can write it down on here. Yeah, and a Telegram. Thank you very much.